there was love. Can you go back for a second? Can you hear me, Professor?
Yes.
Um, would you be able to discuss 8 as well? I think 8, there was some questions on 8 as well.
A researcher recruits a group of volunteers to participate in an experiment to investigate the effect of various treatments on some response variable. How should the principle of replication be used in this experiment? Give each treatment to several individuals. Give all treatments. Okay, so replication is repeating the experiment. Volunteers to participate in an experiment to investigate an effect of various treatments on the response variable. So remember, this is a standard where we're going to compare a variety of treatments. Now we have to randomize to the treatments, but replication occurs within the treatments. We have to have enough people within each treatment to see a difference and a significant difference. So yes, you're going to be giving each treatment to several individuals, but you have to also make sure that there's enough individuals in each individuals getting each treatment.
I selected D because it says conduct the experiment more than once using the same volunteers, but giving each volunteer a different treatment.
Sorry, let me go through all of them first. So C, conduct the experiment more than once using the same volunteers, giving each volunteer the same treatment each time. Okay, no. Conduct the experiment more than once using the same volunteers, giving each volunteer a different treatment. No, you can't do that because with human subjects, giving them the different treatments. Like, so that's kind of what we did when we talked about the Coke and Pepsi, where the person was their own block. But in general, you're not going to do that, because if you give them aspirin and then no aspirin at the same time, that's confounding your results anyway. You can only do that kind of a thing when from treatment to treatment, you're not changing the participant in any physiological way. Let me see. Conduct the experiment more than once using different volunteers each time. Is it this one? See, what was the answer? Conduct the experiment more than once using the same volunteers, giving each volunteer the same treatment each time.
The exam says is the letter A.
Each treatment to several individuals. Yeah, this is the best answer. But you feel like there should be more to it?
Yeah, I didn't choose that one because I thought it was too ambiguous. So
yeah, well, there needs to be something more, right? Because it's like, you got to make sure at the same time that enough treatments get enough individuals. But the other ones are not good. Like, they're very...
Yo creo que la E, porque te está diciendo que...
experiment more than once. No, we don't have to conduct the experiment more than once.
Pero te está diciendo que es para que se pueda cumplir el principio de replication. Por eso fue que yo escogí esa.
Well, that's not what we discussed in class. What we talked about was doing the experiment once and having a lot of individuals in the experiment and receiving different treatments. I didn't say, I didn't say that, like I didn't talk about blocks or anything here. This is a very basic answer. The other ones are convoluted, like conduct the experiment more than once using different volunteers. I never talked about that. I talked about doing an experiment. The only thing where I said that would have been when I showed the block. Let me see if I can go back to the notes. So replication. So here we repeat for the blocks, which I didn't mention it being a block or anything. For a block, you repeat the experiment here and here, but that is a process of randomization. That was under the subject of randomization. the moment I mentioned replication is, I think down here. No, where did I say replication? I know I have it somewhere, but maybe before here. Replication. Generally, the larger the control group and the larger the treatment group, the easier or better it is to establish systematic differences between treatments. So in terms of experiment on people, you want a control group. So at least you have two groups. One is the treatment and one is the control, but you can have more groups. You could have a set of different treatments. But all of those treatments are, individuals are randomized to those treatments, and then you have to make sure that there's enough individuals receiving each treatment. That's sort of what's missing from this question. Oh, over here. So give each treatment to several individuals, which is, I guess, true now that I've shown you that, right? So you want to make sure there's enough individuals in the control group and enough individuals in the treatment group, or however many treatment groups you have. So that is the best answer, but it doesn't mention anything about groups here. And that's maybe what threw people off, and they thought there needed to be a longer answer. But this is obviously not correct. You're not going to give each treatment to each individual, except when we're talking about the Pepsi and Cola case where that was a block design. And I didn't mention anything about being a block here. And also in general, you don't give many treatments to one person because you've affected the biochemistry of a person, and you confound your results, even if you randomize. So we don't do that. And then if you think it was E, conduct the experiment more than once using different volunteers each time. We don't do that. I never mentioned doing that, except, like I said, maybe if you interpreted what I said here as 2 experiments, but that's not, that would have been specifically a block design. So I would have to mention the block design. Block design is not, a standard randomized experiment. This is repeating it within blocks where the men and women are divided. I never mentioned anything about dividing or blocking to repeat experiments. So that's not the answer. But I mean, I can give you guys, I guess, some half points for this. Hey, I would not give any points to B. And anything that says conduct, I wouldn't give anything to B, C, or D, because we don't conduct the experiment more than once. We conduct it once, but we have many participants. Yeah, so I can't give it to any of those because it says conduct the experiment more than once. I never said conduct the experiment. So it feels like you're missing something if you pick A, but B is not the answer. So no, I don't feel comfortable giving. So which one would you think that I should have mercy points for?
Well, I like I mentioned, I answered D because of conducting the experiment more than once, meaning that it would be replicating the experiment.
But we never discussed that. It's not replicating the experiment, the whole experiment. It's just that you have enough individuals receiving the treatment. It's not repeating the experiment.
Yeah, but like you mentioned, that's the reason we chose it, because A felt like it didn't have enough information on the answer.
Yeah, but those are all wrong. You don't conduct the experiment more than once. I chose A because, in my opinion, there's more evidence that the medication does the job, not that the person is more healthy than the others. I don't know that we're talking about more healthy though. Well, who picked A? Who else picked A? Marcos picked A. Yeah, we do not conduct the experiment more than once. We just conduct the experiment once. Different volunteers each time. Conduct the experiment more than once using the same volunteers. Like we definitely don't conduct the experiment more than once using the same volunteers. You're not going to have them stay in the experiment twice. I chose A because the experiment more than once had me in doubt. Yeah, exactly. Yeah, Maite. Yeah, and there's unfortunately many options that say that, but that should be more reason to guide you to A. So you might have been confused with the blocking, but there's nothing here that's signifying blocking going on. So, any other questions? So we have just the firefighter one, which I'm gonna give mercy points. And, no other questions?
So the firefighting is 7, right?
The firefighters was that, yeah. I'll look at what you guys did, but A is the best answer.
Yeah, but if you notice, most of the class were confused in both 7 and 8. So
Well, a lot of people can be wrong about the same thing. It doesn't mean that I have to give points.
no, I understand. It's just
Usually people make the same mistakes because usually people misunderstand the same way, but it doesn't mean that I have to give credit for misunderstanding. It's not a democracy.
no, right, but we're just giving you
It's a right
right.
answer.
We're giving you a rationale, right? We're not just saying just to say it, right? We're telling you why is it that we
Well,
said.
yeah, you really invented in 7, so maybe I can look at see some consistent answers there. So let's look at 15. Exam scores in a large course are known to follow a normal distribution, 64 and 12. Sarah received an exam score that placed her in the 98th percentile of the class. Her friend Hayden received an exam score only half as high as Sarah. At what percentile was Hayden's? Interesting. So you think, oh, I'll just divide by 2, right? And that's not necessarily the case. If you divided by 2, you would have said what? 49th, right? Okay, so you would think it's D. I'll read what you wrote on 7, everyone. Yeah, so you can't just divide by 2 because it's not necessarily, you shouldn't be able to just divide by 2. You have to go and test. You guys are still telling me about the other ones. Okay, so for 15, yeah, you can't just divide by 2. It's not necessarily uniform that you just divide by 2. You have to do the inverse problem. So if I get up, let me get Excel for a moment. So okay, so I guess there's a couple of steps here. So you have to find first the score by doing the inverse problem. So let me put up my Excel document. Okay, so I'm going to use norm inverse. And if I use this one, I don't have to do with the standard normal. I can do this. Oops, sorry, I didn't pick it. Norm inverse. And I have to mention the mean and standard deviation. So the probability, the left side is 98%, and I put it as a probability, so 98, and then the mean is 64, and the standard deviation 12. Now, when I do this, what I'm going to get back, so if I go backwards, I put the probability as a percentile, then I get back the standard deviations from the mean adjusted with the mean and standard deviation to give me the actual score on the test. So the person had 88. Sorry, 89% was the score. So her friend received an exam score only half as high as Sarah. So then you get the exam score. So this has two parts, unfortunately. So then divide that by 2. So their score was 44.5. Now you got to go and do. So let me put this formula in first. So you can see my formula that I used. When I put this in, it's just so you can see the formulas that I use, because this one gave me 89. That was their actual score on the test. So then I divide that by 2, and now I got to do it again. What do I have to do? I have to do the regular percentile. So now I have to get the percentile of 44, and I use the normal distribution to find the percentile. So if I give you a variable, I give you a value, and then you can find the probability. If you do the inverse problem, I give you the probability, and you can find the innate value or the value. So I'm going to put in 44.5. Well, I guess I should just round it. Let's see what happens if I round it. So 45. And then the mean and standard deviation again are 64 and 12. And this will give me the the percentile for the friend Hayden. What did I do wrong? Oh, X, mean standard deviation. I have to tell it I want it to be cumulative. I want the left side. What's wrong here? Yeah, that's the answer. So he's very low score. It's in the 5th percentile, which maybe you didn't pick because it looked weird, or maybe you didn't get this far. So you had to apply the normal distribution twice. So this one, I wouldn't feel so bad if you got it wrong, because you might have got lost and you saw some number easy enough, 98 divided by 2, and you thought that's the answer, but that's the way these are, to challenge you. I challenge you because I can't just give you an easy question. I have to see if you really know. Okay, the specific number here and examine, then divide by 2. Okay, right. So Gabrielle saw that you have to divide by 2, but then you got to go back and get the percentile for the new number. So you have to endure through that problem and see. So the other thing that might be confusing here is I have that the variable is a percentage, and also I'm talking about the percentiles, but those are different things. The units of the variable happen to be percentage. If it confuses you, just always write it out clearly. Like it's 98% was the score. That's the variable associated with the percentile, the 98th percentile. So that's a very high score. Now this friend did really poorly, but in fact, he's so bad being at half. He's actually in the 5th percentile. So it's a really low score to be half of her, it seems like, because it was not exactly a tight distribution, but average score was 64 with a standard deviation of 12 to get down to his 44. You know, you're going to be at least over 2 standard deviations from the mean, or almost 2 standard deviations from the mean. Right? Because it's going to be, yeah. Does that make sense? Should I draw it? Are you guys good with Excel explanation?
Yeah, it makes sense. And if you use the C table, you can get there. But like you mentioned, it could have been confusing for some people just because of the way it was.
You have to keep going because you have to keep. So see it. Yeah, I didn't give the option of 45%. Okay, so the drawing, I can do the drawing as well.
So which is the correct answer?
Is A.
Okay.
Is it correct? Did anybody get A? I would be surprised if you did because I guess
Yes.
challenging. You got it? That's great. That's great. So you have to make sure you've answered the question, right? It's not just about carrying out a familiar calculation. You have to make sure you've answered the question. In this case, you have to do more than just one application of the normal. All right, so I'm going to share my iPad. Okay, so oh. Okay, so X follows a normal distribution with a mean of 64 and a standard deviation of 12. Sarah received an exam score that placed her in the 98th percentile. So about Sarah, she's over here in the 98th percentile. Now, when I draw this, I could be drawing Z or the distribution, but in terms of Z score, well, actually, I don't, okay, I'll do it with the Z score. So this is 0.9800, and we need to find out how many standard deviations that makes her above. So when you do that, what do you get? You look at the table. You get 2.05. So you're going to be 2.05 standard deviations above. Is everybody okay with that, or do I have to show the table? So we need to find Sarah's score. So this is step 1 of the backward problem. Is everybody okay with my selection of 2.05?
Yeah, also if you apply the C formula and look for the X, which is her score, when you get her actual score, you divide it by 2, and then you get Hayden's score. And then with Hayden's score, then you go to the C table again, to the C score again, and that C score is what gives you the percentile.
Yeah, exactly. But I'm just asking right now, were you able to get this out of the table, everybody? Or no one's
Yeah,
commenting?
actually, I got 2.06, yeah.
I got 2.05 in because I just used Excel, but if I go to the tables, I'm gonna find the tables. I didn't teach so this is not in my thing right here. I have to go into the files to get it. Can you guys confirm that you know how to do it? You guys are. I gotta
Yeah,
go back.
in the C table, when you look for the 0.9803, the number is 2.06, which is close enough, I think.
I'm not getting any feedback, you guys. And
Can
then
you
when
hear me,
no
Professor?
feedback is that you don't understand, or okay.
Can you hear me? Can you
Yeah,
hear me, Professor?
yeah, let me just do it. Okay.
Okay, go for it.
So I look up 0.980 inside the table. And 0.98 is about here between these two. So 2.0, it's closer to this side. And that
Yes.
corresponds to 2.0,
6.
2.0. Oh, sorry.
Two
No,
point
this
zero
is
six.
0.05.
No, 2.06.
No, it's closer to this one.
Well, no, it's closer to 0.9803, right?
No, as this is 0.0002 and this is
Oh,
0.0003. But you still
yeah,
get roughly the same answer anyway. Like
yeah.
the 2.05 is how I taught you to get it. So it should be
Okay.
2.05,
Yeah, it was between those two, you're correct. Mhm.
but it's not even, it's closer to this one. And that's how I'm
Yes,
getting my answer. So,
yes, you're right.
okay, so then. So 2.05, I also got it in Excel like this. All right, so now with 2.05, then I find her score. So I say her score is Z standard deviations from the mean, and that's 2.05. Standard deviations are 12 from 64. And what do you get? Okay, so she got 88.6%, which is what we found on Excel as well. So now That's her score, not her percentile. So now we divide it by 2. And you get 44.3 as Hayden's score. And what do we do with that? We have to give the answer as a percentile. So now we have to go back to the regular problem and do it again. So usually students really, they think I'm going to ask them to apply a tool once, but this you have to go back to the tool of using the normal distribution and apply the model twice, okay? But now I'm going to do this with the drawing of, for Hayden, Hayden's way over here. We're going to find out, but first I'm going to standardize, right? So I take Hayden's score, which is his score, and what do I do with the score? I need to find out how many standard deviations away he is. So I do find Z is X minus mu over sigma, which is 44. I don't know if I keep using the decimals. Why am I doing that? Do I need to do that? I mean, I can just round it to 44.
Yeah, you can use 44.3, yeah.
I'll just use 44. Minus the mean of 64 divided by the standard deviation of 12. And you find that he is very low, like negative, right? Below the mean.
Mhm.
So he's almost to, like I said, almost 2 standard deviations from the mean. It's negative 1.67. I have to round it. If I use 44.3, what do I get? Minus 64 equals divided by 1.64. Okay, so it's roughly the same. And then what you want to do is going to be at negative 1.67. You want to find the percentile. So you go back to the table. And negative 1.67, I have to use the negative table. Negative 1.67, you see these are all 5%.
Yeah, I think the result was you can use negative 1.64 like you mentioned if you use the decimals, and that's when you get the 0.0505.
But these will both round to the same answer.
Yeah, they will give you the same
They
answer.
will round to the same.
Yes.
So if you did 1.64 or 1.67, you're going to
Yeah.
get 5% as the best answer out of them. So it's weird because all the other numbers are high. But yeah, this is challenging. So you get the idea. My tests are going to be challenging, but that's because I give you time. So you just don't have a superficial understanding of the material. That I'm going to challenge you more like I do in the quizzes online. Okay, they're more challenging, but all of the other material prepares you for this kind of a test. I can put more sample hard problems up, I think, for the final. But you still have also, if you hadn't had a chance to do the old midterm questions as well, those are equally challenging, I think. And you should study those for the final as well. And I've put those up. Okay, so where was I? I'm gonna finish this. So when you look it up, this is 0.0475, which rounds to 5%. If you used the number 44.3 like I had over there, you would have gotten negative 1.64, and that also would have given you 5%. Oh my goodness. Sorry, my drawings. I think that was the result, which is also 5%. Okay, so Usually my rule is to get the same answers as me. If you round to 2 more decimals than the original numbers, you should get all my answers. So that's why I'm showing this alternative here. The final include all the material. The final, I have online, I posted the framework for the final exam, so you can read about that. It's a document. Let me see. The final exam distribution is posted under module 9. It's called Distribución aproximada del examen final. Let me show you. No, it has a little bit of everything. Well, it has a lot of the newer stuff. I don't do partials because basically you need to know the old material to do the new material. It's all it's a foundational sort of course. What was I going to show you? Okay, I'm showing you the platform. All right, so here on the last module, it says here that the distribution of the final exam. And so that's the format for the final and what's going to be on it. So it's 10% 2 to 5, 20% 6 and 7, but you don't worry about hypergeometric and Poisson. 8, it's going to be 30% 8, which we're going to talk about today, and 40% 9. So it's mostly 8 and 9. And part of the rest. So I have to put regression on there. Regression will occupy your 10%. In module 5. And I've told you here to not worry about those pages with greater detail and multiple regression. All right. Okay, so we're done the test. I'll look at 7. I'll look at 7 and see what you guys wrote. So people who wrote consistently, I can consider your answers. That's why I make you write your answers.
And I think mostly because it was driving the dollars up, or also you could infer
Yeah,
that.
you know, you guys, but yes. I mean, obviously I give you challenging questions, so you think this is a brain buster and you want to think it through. So I shouldn't discredit you guys for trying to
We appreciate
fractalize
it.
these, right?
We appreciate it.
I guess because if I gave you really easy an exam and then you guys went and overthought this one, I wouldn't be so merciful. But I was really pushing you to think. So I guess I can see you're in a different on a different level of thinking and thought, depth of thought. So yeah, I should credit you. All right, let's see 14. Gabriela wants to see 14. How did you guys do on this one? This usually confuses students. 10. Who got 10 right? I'm gonna go to 14. So this is another backward problem. Okay, so this is a backward problem with a twist. That's what I call it. So you have to do it. Yeah, exactly. Gabrielle didn't get the twist. The twist is you have to look for the standard deviation and not the like we usually do, just look for the score, right? But you're using the same tools. It's just you're solving for a different result. So I'll draw this one. Go back to my iPad. So, all right, so in a large university course, the amount of time, so the idea of saying it's large is to justify, using the normal distribution. Because if you have large standardized test, then usually you'll see that the distribution of scores will be normal. So, a homework assignment follows a normal distribution with a mean of, so the variable here is X, or the time to complete, right? One second. I know someone's texting me. Hold on. From the class. So X is normal with a mean of 33. Oh, sorry, I'm reading the wrong one. Time to complete is normal with a mean of 90, but I do not mention the standard deviation. So I'll put it in there as a place mark. It is known that 90% of students complete the assignment in under 120 minutes. So what you've just been told is that 90% of students where we're going to find where that is in terms of z-score corresponds to 120 minutes. So let's find the z-score for that. So go to the tables. Look for 90. And 90 will be between here and here, and it's closer to this one. So I'll pick 1.28. Is everybody okay with that? It's the closest one, 1.28. So I have to come up with these rules so we all get the same answer. So it's 1.28 standard deviations from the mean. So that z-score corresponds to this, which is the X. So this is a backward problem where step one, I find the z, but then I have to find the score usually, but in this case, I'm going to write z equals, sorry, what am I saying? I'm going to write X equals z standard deviations from the mean, or I could just use the original, this formula. You can use either of them. They're the same, give you the same result. It's just that different variables are missing. So if I use this way, I'm going to put the 120 here. The z is 1.28. Sigma, I don't know. And mu, I have as 90. So I've solved for sigma. And that's what you do. 120 minus 90 divided by 1.28 will give you the answer. I could have also done it this way. Over here, so this would be 1.28. The x that corresponds to 1.28 is 120. The mean was 90 over sigma. I don't know. So I'm just I'm doing the same thing. You see, I get the same calculation that I have to make. Because these are the same relationship, just reordered, solving for a different variable. You could use either one. So what do you get? So that's a backward problem with a twist. $23.44. Yeah. Okay, good. Very good, very good. So what you can do is solve the problem manually, check it in Excel. So my approach was, I took my first statistics course I took in a summer. It was 6 weeks. And this is a long time ago, like 1990 maybe. It was in 6 weeks. I was very nervous about it. But what I taught myself to do, because I didn't do anything, I didn't work, I didn't take any other classes, and all I was dedicated was statistics. So I taught myself 2 or 3 ways to solve a problem, so that because I didn't have the answer, I could confirm by attempting to solve a problem all, different ways. So I've shown you how to solve a problem with Excel. I've shown you how to solve the problem with the charts or with the drawings. And so you should do both. You have enough time to do both. Confirm your answer. And if you're not getting the same answers with 2 different methods or even 3 different methods, step aside, put it aside, and do another problem. It'll shake up your brain a little bit and go back to it. And that's my advice, best advice. All right. Okay, so back to the test. Any more questions about the test? All right, so the next thing I said I was going to discuss, so I said like, oh, let me just finalize or summarize. I'm going to look at your answers on 7 and see if I give you guys some credit for answering E. For 7, most of you answered E. Anybody answer a different option? Because size of,
Yeah, I answered yeah, and I've heard most people say
anybody else answer something else, like B, C, or D? No? Okay. But anyone not get E and they picked a different one? I guess not. All right. I don't want to reward, I can set it up to reward you for partial marks, but I'm going to check that you had a good rationale and you weren't just guessing. The idea of the test is for integrity, right? Like I want to make sure authentically you know what's going on. All right, so I said I would also see I will see if there's any questions you have about right, so unit 6 and 7 are using the same notes. I just take some special time to go deeper into different kinds of probability distributions in 7. In 6, what is maybe something we can talk about? If you guys get it, I'd rather not talk about it, but Bayes' rule. Close your eyes, I'm going to scroll through. So Bayes' rule shows up. Oh, I kind of wanted to show you something. I'm doing this research. I'm going to show you something here that I did to make a point about independence. No, not this one. Let me share this with you. So this is some results of research that I'm doing, and I've identified 4 groupings of states without telling you all the details. Lots of numbers here. But when you do large studies, it's, these are actually the candidates and the sections of the CPA exam. These are actually the statistics on the number of people and the number of sections they wrote on the CPA exam over a 5-year period. And what you see with large studies is that the patterns are pretty consistent. And this is what is interesting. I've included international candidates in this row, and this is the number of candidates. And the domestic candidates, so those are Americans living in America, or sorry, writing in America, in this row. Okay, so that's what you have here. Now just look at the percentages. They're easier to stare at than the numbers. And so those are the number of candidates. And then I looked at the number of sections, because on the CPA exam, there's 4 parts, there's 4 sections, and people can write, and it was certain rules, but you can write up to 4 sections each sitting. And you can write, there's 4 opportunities to write through the year. So you can write up to 16 if you failed every time. So you can write about 16 sections, but that's the maximum. Anyway, the point is that if I look at the candidates or I look at the sections, you see how the numbers are consistent. So it just shows that like 61% compared to 63, it was about the same, 33, 32, 6 and 5, 0, 0. It's just showing that more students, more sections, and look how like they're just almost exactly the same. So I really like larger population data because you get to see these consistent patterns, and it's very easy to catch if you have an error or if you have a change, like a dramatic change in performance, in this case for exams. Again, look at the domestic. So this is about the candidates, and they have pretty much the same proportion of sections. 39% are falling in group 1, 1%. So it's consistent, and these groups are consistent as well. So consistently, candidates are going to the same, the same preponderance of candidates are going to the same set of states. This is dividing states. So you guys just see my pattern, the patterns. What I mean, looking for patterns. And then here, what I did was look at the pass rate. Again, it's a lot of numbers, but I'm going to try to guide you. This is the pass rate for international students and the domestic students. So clearly the pattern is domestic students do better. In this one, in this one, in this one, in this one, they did better than the international students. That's the number or percentage of people who passed. And then this is their average score. And you see it's 72%, 73%, 72%, 72. So it doesn't matter consistently in the groupings of states. So whatever I did, I divide up the states with some logic, but consistently the average score was 72%, no matter what grouping I used for the domestic students, and consistently, except for here, but this is because it was a very low sample, but pretty much consistently it was 68, no matter what grouping I did. So this is an example of independence, okay? That it doesn't matter which group, I can say that the average score was 72% for domestic candidates, independent of the group. So that's an example of average score. Pass rate, there's a little bit of change. Depending on the group, the pass rate is different for domestic candidates. So I don't know if that's interesting to you, but just showing you that that would be independent here. So it doesn't matter which group I go into, it's about 72, 73% every time. All right. Showing you something practical. So back to the notes. All right, so scrolling through. Hopefully you've got all this done. I end up at the Bayes rule over here. Any questions about Bayes rule? Once you start solving it's less confusing, but there's a lot of symbols everywhere that can be confusing. So we could use the conditional probabilities to solve for what's called the posterior probabilities. I never use the terminology, but I reverse to find out about the probability of B given A, I can use the conditional probabilities. So whenever I reference sections in the textbook, I'm talking about the Newbold's textbook, but you could find the equivalent sections in the textbook Bowerman that you're using. So if there's no questions about Bayes' rule will not be on the final according to my exam distribution. Oops, sorry. I have people outside. I don't know if you hear them arguing. According to the approximate exam distribution, Bayes' rule does not come on the exam. I haven't made that really clear here, have I? Yeah, so the Bayes' rule won't be on the final. Then the means and variances will be on the final exam. What I've done here, so this is all very confusing, except when I get to the point where I actually solve problems. And I solve this problem, and I have given you the answers for the rest. And according to the final exam distribution, I am going to give you one question that mimics those exercises from page 42 to 48. So page 42 to 48 begins here. Okay, so you need to know how to use the rules of mean and variances and apply them. So have a look at those. And if next week you need some help with those, unless you want help right now, I've given you all the answers. So it means you need to sit down and attempt these exercises and see if you can confirm your understanding by checking the answers, okay? So what I usually do is take one of these problems and I adapt or I modify them. But you should be able to apply rules of means and variances for the final exam. So if you guys are good, you know, no questions about Module 7 right now, I'm going to go to Module 8. Module 8 is the easiest of all, in my opinion. I already taught you how to use Excel to display the binomial distribution given the parameters, but I want to go again. If I mentioned it before, I'm repeating myself, but it's important to say, you know, if you just want to be able to click, you know, keys in a calculator or enter numbers into Excel, that's not what you're here to do, right? I'm trying to teach you the theory and the development of the formulas behind the results that you get out of a tool like Excel or your calculator. So we're going to take some time to do that and looking at the binomial distribution, and then talk about sampling distributions. Most of my discussion of sampling distributions is provided in these videos here. That's what most of these videos are about. Okay, so I repeat here. I just said, Patricia, that Bayes' rule will not be in the final exam. However, you have quiz questions and exercises where I will, I do test it. So to avoid frustration, it's better to learn it. Okay, binomial distribution. So this is the binomial formula, this formula here. And this is the distribution here. So if you remember, X is the number of successes out of n independent trials. So the number of successes can be no successes all the way to all successes. Success is just categorizing the thing that we're interested in looking for when we conduct a binomial type experiment. What we do is observe either participants or products on a manufacturing, production, or assembly line, and we observe them in the same setting, and we look at them, or we measure them, or we do something about to capture a characteristic of them, and record if we find what we're looking for or not. So whether a product has been assembled properly, or whether the example we use, a person holding an umbrella that we observed coming into a mall. And why would we do that? Maybe we want to know how many, we want to know how often we have to, mop up the entryway, right? So we want to observe to see who's bringing in umbrellas that are all wet. Or we want to know how many bags we have to have there, because sometimes they have bags in the mall where you can wrap up your umbrella and avoid dripping water to go throughout the mall, which is an insurance hazard, and it's also a human hazard. So you want to observe to gather information about what to expect. And we start with already, I give you information, and then we say what we can expect to see. So these have been established, what we're expecting to see, n possible, our sample size is n. That's how many times we're going to observe, and that's the symbol that I use, right? Little n for sample size. And P is the probability of seeing a success, seeing what I'm looking for. So what is this whole thing? What is going on? So I'm going to use the example of flipping 4 coins that we're familiar with, where the possible outcomes have been sorted so that I can easily visualize 0 successes, 1 success, 2 successes, 3 successes, or 4 successes. So the maximum is 4, the minimum is 1 if I'm flipping coins and I'm looking for the number of tails. We already know we're going to flip 4 times, so that's the number of trials. And the chance of having a success, a tail, is a success, on any flip is 50%. But what I really want to know about is overall of the 4 flips, what's the chance of getting 0, 1, 2, 3, or 4 tails? Now, because I was able to write these down and count, knowing that each possible outcome is equally likely, I can generate the probability distribution that we generated here. So we did this already. Is everybody good with that? You remember we did this already. So as I explained earlier, I like to approach things in 2 or 3 different ways to see if I get the same answer. So in general, we have a rule that we can use. In general, we'll develop a rule, which is going to be the formula for the binomial variable. So let's derive this. Let's focus on this one here, 0.375. How do we get this number in a different way? So I want to find the chance that there's 2 successes, but I don't want to use this approach. I want to do this with a formula. So let's see. Let's take this one. That's one of the 6 ways of seeing 2 tails. So that probability we can express as the probability of a tail and a tail and a head and a head. Now, because each trial is independent, we can just multiply that and means multiply probability of tail times the probability of tail times the probability of a head times the probability of a head. So I can just multiply. And if I just multiply, I get 0.0625. That is not 0.375, right? That's not the answer here. So how am I going to get this answer here or here? The answer that we got here. Well, the fact is that's just one of these. Now, before I go on, I want to create a general formula. I found the answer for this specific case, but in general, what did I do? I took the thing I'm looking for, tail, and there are 2 tails. And I multiplied the probability of each tail together. So what I did was took the P, which is the probability of success, and I multiplied it together. So in other words, I put it to the exponent 2. And then I have this term here. So what's another word for head? Well, in this context, head is a failure. And because there's 2 successes and there's 4 trials, then we have 2 failures. So what we have is a failure, the probability of which is 1 minus, and there's 2 of them. So we have tails probability, which is probability of success to 2 successes, times the probability of failure to 2 failures. This is the general formula, but I've got to even go further and put symbols on the 2s, because not every problem is going to be about 4 flips or 4 trials. All right, so I'm going to take this with me, realizing that I've only found the probability of one of these using a formula, but there's 6. How do I know that this is going to be 6, this is going to be 4, this is going to be 1? How do I know that? Well, what have we done? We're looking here to find how many ways are there to see 2 T's. So how many arrangements are there? In fact, you should have learned about this in high school. You may not have, and maybe you learned about it in college or university, but there is a mathematical formula for this. Four possible positions, right? First, second, third, and fourth. And 2 of them need to be successes out of the 4 possibilities. To calculate this, which we write like a vector, we put this long brackets around it, and we call it 4 choose 2. This is a combination. This is combinatorics. And you may have learned about this. To calculate this for probability, it's 4 factorial divided by 2 factorial divided by 4 minus 2 factorial, which factorial just means 4 times 3 times 2 times 1. And this reduces to this, and you get the answer 6. So all of that, maybe you've never seen that before. How many of you have seen that before? How many have seen that before? Factorials and combinations. My ingeniero, of course. Seen it before. Okay, so you've heard about it, so only like 3 of you vaguely remember that. Maite. Okay. So out of my 21 students, only 4 people vaguely remember. 5. So you should be able to take this class without knowing that. Sorry.
Industrialized nation is going like this, America is going down.
Oh,
And
gee.
that's because people.
What happened here? Can you hear me? I don't know. I turned something on. Okay. You can speak. Somehow I turned something on. All right. So, so a few of you have seen this, others most say no. Okay, so don't worry about it, but all I need you to remember is what we're doing here. So what we're doing here is finding the number of ways to see 2 successes out of 4 possible observations, right? Or in this case, flips. Same here. If I want to know how many possible ways are there of seeing 1 tail in 4 flips, or 3 tails on 4 flips, and you can do this with your calculator. So I asked you to get a calculator, a particular calculator, and in the syllabus, actually, I don't know if I put it in the syllabus. I put some symbols down of what you should have on your calculator. But anyway, let's pretty much avoided that by telling you to buy a specific calculator. So let me go to the calculator and show you where this is programmed on your calculator, okay? Okay, let's go to the calculator. So on your calculator, you should see above the plus, there's NCR. Above the plus, I'm flashing it, NCR, and it's in blue on my calculator. So you should be able to activate it by using the second key here. Okay, so what we're going to do is say, for this problem, 6 second function NCR 2 equals. Oh, that didn't work. Not 6. Why did I say 6? 4. Sorry. So 4 second function NCR 2 equals 6. I was thinking of the answer. Okay, I'll do that again. 4 second function NCR 2 equals, gives you 6. And that's that. That's how you do all that. It's all programmed on your calculator. So if I was going to do 4 choose 1, I should get 4, right? So 4 second function NCR 1 gives me 4. So at this moment, I want to emphasize that if you're using this calculator, which I highly recommend, you need to make sure your calculator has order of operations on it. And the way you can do that, and this is something I just learned last month, so it might not be in the old videos. So let's see how we're going to set up our calculator for order of operations. I may have mentioned it in one of the first classes. but I'll tell you again. So we want to go to second format. No, now I have to remember. Is it this way? Yeah. Okay. All right, that's it. All right, so what I did was click second format on the calculator and you format the settings. And this is like 9 decimals, and scrolling down, I want it in degrees rather than radians. It's using this kind of dating scheme. I'm not sure what that's used for. So month, day, year. That is for finance. And then this one, when you get to, mine is in AOS, which this observes order of operations. I honestly don't know what AOS stands for right now, but that's what you want it to be in so that it honors order of operations. Addition over subtraction. Anyway, I have to look it up what AOS stands for. Alternatively, this, if I do this, if I hit second set, I change it to not use order of operations, but I want second set to use the order of operation. Because what I'm going to show you is going to be very easy that it's in AOS. So make sure it's in AOS. So second format, scroll down past these things. To this point, if it's not AOS, then hit second set. If you see CHN, hit second set again to get it back. And that's all. All right, so let's talk a bit about what that is doing, or how that how we use that. So that's called the binomial coefficient. Going back to the notes now. So this is called the binomial coefficient. And let's just say a few things about this. So this is the binomial coefficient. This is the formula. This is the formula your calculator is using. Notice that the binomial coefficient has perfect symmetry. 6 choose 0 is 1, 6 choose 1 is 6. On this end, 6 choose 6 is 1, 6 choose 5 is 6. You see that it's going to be 1, 6, 15, and then 15, 6, 1 with something in the middle. So there's symmetry in the binomial coefficient. There's always symmetry. If people are still not even sure what I'm talking about, let's talk about this for a moment and talk about the symmetry, and then I'm going to go back. So what does 6 choose 0 mean? There are 6 possible outcomes. And how many ways are there you're going to attempt something 6 times and you want to see no successes. So how many ways are there seeing no successes? So in other words, all of these are failures. How many different arrangements of the F's can there be? do another one. I'm still waiting for you to answer that one, but. So this is 6, choose one. How many ways of seeing one success out of 6 tries? I have 2 questions on the board here. For the first one, how many ways of seeing 0 successes out of 6 tries?
One way.
Very good. There's just one. I'll put it in blue. So try that on your calculator. So you can see that visually. The reason why we need the calculator is because we're going to think about more trials, not just 4 or 6. What about 1,000? What about 10,000? That's why we need the. That's why we need the calculator and the computer. So if I'm going to do 6-second function NCR 0, it should be one way, right? And I get 1. What about the other question? How many ways are there seeing one success out of 6 tries? Here's one way. So, when all else fails, you just start looking for patterns. Another way of seeing it is,
Would be 6, right?
yeah. That's the second way. Third way. So basically scrolling the S through will show me all the ways. So you quickly see there's a pattern that there's only 6 ways to scroll. And so it's 6. On the other hand, what about this way? Okay, what's 6, choose 6? Before I do that, let's do 6, choose 1 on the calculator. So go back to the calculator. So clear 6-second function NCR 1 is 6. Okay. So what about 6, choose 6? What's the answer? How many ways are there to see 6 successes out of 6 trials?
Well,
Sorry?
it's also 1, just like 6 to 0.
So now you see, right? 1, 2, 3, 4, 5, 6 slots. How many ways to see 6 successes? Well, I'm just flipping. Now I'm calling them S, but it's the same restriction. I can't move. I don't move anywhere, right? It's just, there's only one way to see that they're all successes. So that's one way. So in this way, that's why we get that symmetry. So 6, choose 0 is 1, 6 through choose 6 as 1. And in fact, in general, n choose 0 is equal to n choose n will be equal to only one way. Because there's only one way to see no successes or no failures. So if I do, so we can avoid having to draw every time or avoid tearing our hair out because we have computers, but this is what it's doing. This is the base. Knowing these is really, it really simplifies your calculations. So this 6 choose 5, what would be the answer there? So you have 5 successes and 1 failure. So that looks like this,
Yes.
where I'm just scrolling an F through 6 spots. So it's going to have the same answer 6 ways. Everybody's getting quiet. You guys, what's happening? I mean, I don't need to tell you this because it's all in the videos. But if you're here, it's because you either didn't see that or you want more explanation. So that's what I'm doing. So I'm going to move the F through and show all those ways. So you get the idea, I hope. But because we see the pattern now, we don't have to do this every time. So in general, that's true, but also n choose 1 will always be equal to n, which will always be equal to n minus 1. Those will all be the same. So we have symmetry in the binomial coefficient that tells us how many different arrangements there can be of our successes and failures. What about the rest of the formula? So let's get back to the formula and put this all together. So what we figured out is if we want to know the probability of 2 successes out of 4 tries, we're going to apply this formula because this is going to say how many arrangements are there of 2 successes. Now notice I use the letter K. K represents the particular. K represents the particular. Sorry, Corales, can you mute your computer? K represents the one you're interested in, because remember you can have no successes, 1 success, 2, 3, 4. And I refer to it as your special K. This is like, your serial. This is the one out of the 5 possible outcomes you're interested in. So K successes. So the probability of success to K successes, the probability of failure to n minus k failures, because if k are successes and I try n times, the remainder is n minus k. So that is the formula. We've applied it just once here. I could apply it 5 times to get this whole distribution here. So basically, that's all I explain where this comes from. So this is the formula. This is the formula applied with k0. I put 0 here, and then n minus k, which is 0, is just n. What if k is 1? Then it's n choose 1. What means 1 success? So the probability of success to 1 success. Failure to n minus 1 failures. All right, so let's apply this, and then you guys can read through. I basically repeat myself 3 times to solve this. So going back to the ESP example that we learned, or we explored this type of an experiment, and I just identified it as a binomial experiment. 100 cards are presented to an individual being tested for extrasensory perception or telepathy. There are 4 possible outcomes on the cards: star, circle, wavy line, or square. And we're going to assume that every time a card is displayed, it's reshuffled back. So it's with replacement, okay? So each time it's equally likely to get any of these. So that means there are 4. They're each equally likely, so it's a 1/4 or 25% chance to get any of those symbols. If a person is able to guess 50 or more cards correctly, they will be considered to have ESP. So 100 cards will be seen. This is a binomial because the success we're looking for is a correct guess. The chance of that is 25%. And we're going to do this 100 times. So that is the layout. It's a binomial. And now I ask the question, what's the probability of guessing at most 2 cards correctly? So what you would have to do to solve this is generate the distribution but only for 0, 1, and 2, right? Because that's at most 2 cards. It's 0 cards correct, 1 card correct, or 2. So we have to apply the formula 3 times. 0 or 1 or 2, which means adding, right? Because they're mutually exclusive. So I'm going to apply this formula 3 times. 100 choose 0, so 0 successes. 0.25 to the 0. 1 minus P is 75%. So this is the success with 0 successes, failure with 0 failures, with 100 failures. Now we're going to plug this into our calculator together, and you realize that they're all going to be 0, right? Because the chance of only getting 2 right is very unlikely. It's likely you're going to get some of those just by complete sheer luck. You're going to get them right. And that's what we're trying to establish. What's the percentage? What's the luck? So if you put these in your calculator, I'll just do one of them. You'll see you'll get 0. It's just to practice entering this into your calculator. But as I showed you last class, you can easily do this on Excel as well. We'll get to that in a minute. So just to practice. And if you don't have the calculator, I can't help you. But this is how I use the calculator. So if I want to enter this 100 second function NCR 0 times 0.25 to the power 0 times 0.75 to the power 100. You should be able to do that to get this answer, which is what I have on the notes. I'll just show you this. Now, to do this manually, so what you do to make sure you just as a personal check, these should always add to 1, and these should always add to n if you've done things properly. And this is my special K. It's the number that's here. Remembering this is a discrete distribution, and we're actually able to calculate. We're actually calculating the values at the probability at, or probability of x equals a specific value, right? We're able to list all the possible outcomes and calculate the probabilities. So to calculate this on our own, without the calculator, this will always be what? What did we just learn?
1.
So always be 1, right? Because if you have no successes, they're all F's, and there's only one way to see that. This will always be 1 because anything to the power of 0 will be 1. So the only thing you're really going to stick in your calculator is this. So you can blindly punch it in and get the same answer, but all you really have to do, and you're simplifying, all you're really going to do is 0.75 to the power 100. And when you do that, 0.75 to the power 100 is equal to that still, right? So it's that answer. So the answer is 3.21 times 10 to the negative 13. That's what it means. So we're going to consider anything 10 to the negative 5 as 0. Okay, because that's going to be 0.0000. No, that's like we're going to stick with 4 zeros. So in probability, in the probability material, always keep 4 decimals. Got that wrong. Okay, so this one, for instance, this is going to be, so this says negative 13. You have to go 1, and then basically it's 12 zeros in front. So this number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 3, 2, 1, which is clearly, I mean, I'm only going to cut off here, so it's pretty much 0. And they're all 0. So you can practice that to feel a little more comfortable. Remember, you can always check your answers with Excel. But I want to see you applying the formula. So when you get your results, let's go back to the notes. So in the same way, this one's going to be 0 for x equals just 1 correct card, 2 correct cards, will be 0. And when you add 0, 0, and 0, you get 0. So the answer to that is 0. There's a 0 chance. In other words, you're likely to get at least 2 correct out of 100 just by chance. So let's ask for the number of cards correctly guessed that will give us an answer. So what about x equals 20 correct guesses? So now let's punch this into our calculator. And see, it's got a 5% chance of getting 20 correct just by guessing. So let's put that into the calculator. So I'm going to put this in my calculator. So 100, second function, NCR 20. I can say equals or even just times. It'll give me the answer for 100, choose 20. So that's how many ways. Imagine 5.36 times 10 to the power 20. There's a lot of ways to see. You don't want to be listing this, right? We want to use the calculator to help us, because listing, I don't know, how many is that? That's hundreds of trillions or thousands of trillions. All right, so then we're going to multiply that by 0.25 to the power 20 times 0.75 to the power 80 equals, and that's my answer. So it's very wild until you get down to the final answer. So this is 4.93%. You want to see me enter that again? So that doesn't simplify easy, right? I mean, it simplifies when I use the calculator, but I can't simplify it like I did that previous exercise. Okay, let's do that again. So clear my thing. So 100, second function, NCR 20, and then I just keep going. Times 0.25 to the power 20. Times 0.75 to the power 80, and then you get the answer. Now, if you're not getting my answers, you need to adjust your calculator to have order of operations. So there's a 5% chance by just guessing, you'll get the right, 20 right. So let's do this in Excel as well. Let's do this problem in Excel. And I'm going to use the binomial. I mean, you could type it in as a formula, but let's use the binomial here. And I'm going to use the binomial distribution, and it asks me to put in the number S. That's my special K, because I want 20, right? That's what I said, 20. But there's a total of 100 trials. And the probability of S, success, so S stands for success, right? The number of successes. So the probability of success was 0.25. And I want to be cumulative. In other words, do I want to be cumulative? This is a question for you. Do I set cumulative to yes or 1, or do I set it to 0 to answer this question? The question being, let me go back to let's get rid of this. So I want to add in my Excel. There you go. Oh, what happened? I lost my Excel. Okay. So the question, whoops, drop the iPad. So the question for you, that didn't work. I want the split view. There. Cumulative 0 or 1? To answer this question. Are you guys trying this? Well, if you don't know the answer, you can just test it and see. If I put 1 in, or if I put 0 in. If I put 0 in, it's not accumulating. It's not giving me a probability x equals 0 plus x equals 1 plus x equals 2 plus all the way to 20. It's just giving me probability x equals 20, which is my answer. Okay, so you need to use this formula here with 0 inside. Drop the iPad again. Are you guys paying attention? I don't have to be here. I have things to do too. Are you guys trying this, or can we just call it a day?
Yes, I put it in Excel. So 0 would be non-cumulative, right?
So the 0 is just to give you x equals 20. If you put 1 in,
It will give you the summation of.
it will add up. The nice thing about Excel is that it does things quickly so that you can play around with it. Okay, so that's the wrong answer, right? Because that's, what is that doing? That's giving me all the results. So if I put this in, so what I'm going to do is I'm going to generate the distribution. So I'm going to put, like I did last class, x equals x and probability x equals x. And I'm going to put, always don't forget the 0. I'm going to mess up if you don't remember. Let's start with no successes. So I'm going to go through.
Yeah, the cumulative will give you all the success up to 20, right? Instead of just 20.
Right. I'm going to prove it. Because actually most tables, if you find a table online, it's going to do cumulative and you got to know the difference. So now I'm going to take this formula and put it here and change this into referencing here
Yeah.
and then copy it all the way down. All right, so we see here for 20, we got the same answer. That's just at 20. But I would generate the whole distribution for all of them. And let's say if I sum them from here all the way down to 20, that's where that number comes from. Okay. Okay, so you know the difference between 0 and 1.
Yes.
Okay. You can take a screenshot if that helps. Remember. Okay, so let's solve some problems. Oh, wait, let me do the last one. Last one in the notes. Is so we calculated for 20. We use the non-cumulative on Excel and got 4.93. We also put it in our calculator and got the same answer. So that was nice. So now, what is the probability that someone who is simply guessing will be found to have ESP? So what is simply guessing? I would have to add up all the probabilities from 50 to 100. Now, because we have Excel, we can do that. If we had to do manually, it would be very time consuming. If we didn't have like a standard probability, 25% is kind of a standard. What if our probability was 0.37896, some ambiguous number? And we don't have a table for that, because in the past, there were tables. There's tables generated that people would refer to make calculations of what to expect. But it was realized, we could do this in approximation, and that's something we're going to learn in this unit or module as well. How to do it in approximation when it's very time consuming or inaccurate, because you can make a lot of mistakes if you have to manually do this by adding. But because if we have Excel, it's kind of disrupted this whole notion of approximation. But it does build up into the theory that you'll see in a bit. But for now, I want to just practice before we get back to this, how we do this a different way than just using Excel and using approximation. I will do some other exercises. Okay, so we're gonna do a few exercises together, and then maybe talk about sampling distributions a bit, or maybe I'll probably leave you for that because this might take 45 minutes. Yeah. Okay, so let's try these exercises together. I'll ask you to take a, get some water, come back. Let's try as many as you can. And in 5 minutes, we'll meet back here. Okay, I'm back. I think that was 10 minutes. Okay, let's do these. Have you tried any of them? The answers are, most of my answers from here on out are in the notes, so you can see the answer, but I guess understanding is a whole other thing, right? So how would I do this problem? I know this is a binomial because I can identify the variable x as the number of successes in n independent trials. Let's see what we can fill in here. What's a success? And what are the trials? And what's the probability of a success?
The success is getting the 5.
Okay, so a success, let me put it somewhere else. Let's put it here. So there's 6 possible outcomes. 1, 2, 3, 4, 5, 6 each time you roll a die. And the success in our case, what we're interested in is seeing a 5. That's not an S. Let me make it clear that it's a 5. It's 5. So what are the trials? How many trials are we going to do?
6.
Right, so trials are 6. And so looks like a binomial. If I can identify x, n, p, and k, I have a binomial problem to solve. So x can be either 0, 1, 2, 3, 4, 5, or 6 successes. N we said was 6 trials. What's the probability of a 5 each time I roll the die? So let's define that. P is the probability of success. Oh, I have to open the chat. I don't know. I closed it at some point. Right, Marla. So this is 1/6. Now, note that I'm going to use the fraction. And if you guys don't feel comfortable with fractions, work your best with them. If you want to convert them to decimals, you know, you lose something. If you want to convert this, this is going to be 0.16666. Like, at what point do you round it, you know? So we're going to try and operate with the fractions, and I'm going to show you how. So trust me. Okay, so that's 1/6 the chance of getting a 5 each time. On each trial. So finding K makes us look back over here. So which of these am I interested in? Do I want to find 0 successes, 1 success, 2 successes, 3, 4, 5, or 6 successes? Because of this word exactly 1, that's how I know that what I want is this. I just want 1 success. So K is 1. So there were 7 possible things I could compute, but I just want the 1. So how do I do this? I can do this in Excel. I can do this on my calculator, but I'm going to write down the formula first, which I expect to see from you, is that you write the formula. So the formula looks like this. X equals 1. Let me erase this my way. And then I make a bunch of brackets. I make the long bracket. Well, I don't know a bunch of brackets, but okay, I'm going to make the long bracket, and that's going to have an n here, which is 6 trials, and I'm interested in 1. So remember, the K goes in here. And then I'm going to multiply by the probability of success, which is 0.25. And this is the number of successes. And then I'm going to right away put 1.75 here. Let me make it a little clearer. And I put it to the number of failures. Well, if there's one success, then there has to be 5 failures because these sum to 6.
You said you were gonna use the probability of 1 in 6, right?
Oh, sorry, I'm thinking about the other problem. See
Yeah.
what I do all the time? I'm thinking about the last problem that we did with the ASP. All right, so we're going to use 1/6. Thank you. So that's why I was talking about brackets.
Yeah.
So then I'm going to use 1/6, and then this one would be 5/6 because it's the failure. So these ones have to sum to, let me do this a little clearer. And these have to sum to 1. So I can simplify this before I continue. I'm going to simplify where I know 6 choose 1 is what? What did we learn about anything choose 1? If it's 1 success, it's just an S that I have to scroll through 6 spots or 6 alternative arrangements. The answer is going to be
6.
So this simplifies to 6. What about this? What does this simplify to? One 6 to the power of 1 is just 1/6.
Mhm.
And then, so in fact, these will cancel. And all I'm going to have to put in my calculator is 5/6. Let me erase this for now. The power 5. So that's all I'm going to put on my calculator. 5 divided by 6 to the power of 5. And that's my answer. Yes, and the answer is, I'm going to put here as 0. Let me make it bigger. 4019. So always 4 decimal places, okay? But then you can see your answer is this one. So let's put it in our calculator as though we did not simplify it. Let's do it from the top. So from the top, well, the simplification, it's going to be clear my screen, 6 second function NCR1 times, you can use brackets, or if you know, because we put it in order of the operations, it should be fine. So times 1 divided by 6, let's say you just didn't know how to simplify it all, times, I think you have to put this one in brackets, 5 divided by 6 close to the power 5. And you get the same answer. Do you want to see that again? So all these ways, I should also be able to put it in Excel and get the same answer. All these ways should give me the same answer. All right, so one more time in my calculator. 6 multiplied by 1 divided by 6 times bracket 5 divided by 6 close to the power 5. So y to the x is a power function. You're going to need that one if you don't know. One more time. We're good. Okay, so let's do a few more. I think we can do that and then go. And I'll leave you to work on sampling distribution of a statistic on your own. And when we get back, when we meet again, we're gonna wrap things up to move into inference, and we're gonna have 3 solid weeks of inference, which is good, And it's going to depend a lot on your knowledge of everything, but mostly of normal distribution. Okay, so all right, let's not do number 2 because we already know that one and we're tired of that one, right? Let's do 3 and 4. Okay, good, Edgar. Yes, yes. So you should be able to get the right answers very easily now. Two. You're gonna make me do number 2. Okay, so let's do this quickly. So I said X, N, P, K. If we can fill these in, then this is a binomial. So there's N is 4. What am I just? N is 4, and P is the chance of a success. The success in this problem is heads. So success is heads. I'll write it down. So this is pretty easy. You know how to fill in, formula. The issue is separating, teasing apart each trial from the overall N trials. Okay, so each trial you're looking for a head. On the overall trial, you want no fewer than 2 heads. So let me finish this. So each time, the probability of success on each trial is half, right? Or 50%. That's an easy decimal, so we can use it. And so remembering K, we have to go back to the possible outcome. So go back here, which is K. So we have to read. It says no fewer than 2 heads. So what's no fewer than 2 heads? So
2, 3, 4.
2, 3, and 4, right? So we have to add up for 2, 3, and 4. So we have to repeat K 3 times. So let me erase, clean up my screen a bit. So what I need to do is X equals 0, X equals 1, and X equals 2. No, I have to go to 2, 3, and 4. Let me fix that. 2, see, so I go into automatic mode and I'm wrong. So I'm going to go to 2, 3, 4. So when I lay this out, this is going to be 4, choose 2. This one will be 4, choose 3. And this will be 4, choose 4. And then it's going to be success, success, success. But I want 2 successes here, 3 successes here, and 4 successes here. And then this is failure over here, right? So because it's 0.5, I can write, because 1 minus that is 0.5. And failures will be 2, 1, and 0, because these need to sum to 4 all the way down. And the probabilities need to sum to 1. So simplifying, as you asked me to show you, so this will simplify to 1. This will simplify to 4. This one you actually have to figure out, but we know that one is 6, but we'll get that after. And then these also simplify to 1. Well, that simplifies to 1. So you've simplified things a lot, so you can punch those into your calculator. And then what you have to do is sum all the results. So I want to see you putting these formulas down. So you can't just use Excel. You have to show me your formulas. Yes, you have to scroll until you find CHN. Edgar, very good. If you had the video, you could go back and see it, but you're trying to do it. Anyway, I'm glad you got it. So now getting my calculator back is for second function NCR2 times 0.5 square times 0.5 square. And then you have to say equals. So we already knew that, but let's put it down. 0.375. Ooh, that's not good. I need to do that better. More room. Okay, so 0.375, and then the next one. So what I can do is I can store that by hitting store 1 and clearing my screen. So that's stored in storage 1. Then I can put a 4 times 0.5 to the power 3 times 0.5 to the power 1. Now, you can use Excel to show your results, get the results, but if you are a person who likes a challenge, you should be able to do it in all ways. Okay, so 4 times, just double checking, 0.5 to the 3 times 0.5 to the 1. 0.5, and then store that in 2, clear my screen, and then all I have to put is 0.5 to the power 4 and store that in 3. I'm going to go to Excel to show you how I do it in Excel. So recall 1 plus recall 2 plus recall 3 gives me my answer of 6875. Very good. Now, if you did this in Excel, you couldn't use cumulative because cumulative will give you 0, 1, and 2. So you would have to do 1 minus to get this answer, 1 minus 0 and 1 to get this answer. So you have to know what you're getting out of Excel. This is why I teach you, the limits. So Excel will just give you the left side. It will only give you the results for the left. So you'll get 0 and 1. So you would have to subtract those from 1 to find 2, 3, and 4. Actually, I don't have time to go into Excel, but you can verify that. All right, so let's look at, what did I say? Questions 3 and 4. 3 is quick. one. Suppose that 60% of a herd of cattle is infected with a particular disease. So X is the random variable representing the number of cattle that are infected. In a sample of size 5, let Y denote the number of cattle that are not infected. What is the distribution of Y? Right, so it's going to be P of 0.4 and an N of 5. That was not hard. But you need to know your N and your P to use and apply the binomial. Okay, so the next two, before we go, we don't have too much time, maybe we can just do one. But I encourage you to do all of these, and you do have the answers, but it's really important that you understand. You know what, I'm going to do both, and if people have to go ahead, but you can watch the video later, okay? So I'll do both, and then we'll go. And I'll say I'm done with binomial, and it's up to you guys to get back to me with any questions you have. So for this one, what is it that, what are we looking for? What is the success? Usually you can go to the last sentence. Well, it's either what you've been given and work with that, but really you have to answer the question. So you have to go to the last sentence. The probability that 6 patients or less die. So death, unfortunately, is what we're looking for, okay? So death. So there are 7 people to observe. The chance of death is 70%. So either 0, 1, 2, 3, 4, 5, 6, or 7 people die. For this problem, our special K, what we're interested in is finding 6 or less. So we would have to add all those up. What's another way of solving this problem that's less tedious and prone to error?
Put the cumulative in Excel from 0 to 6.
You can use it Excel for 0 to 6, but what's in a more efficient way? What's the most efficient way to solve this? Something that we learned.
1 minus 7.
Yeah, so calculate. So K would be 0, 1, 2, 3, 4, 5, and 6, or 1 minus the probability that X equals 7. So just don't forget what your goal is. Don't, because there's, there's some calculations that you have to do. Don't lose sight of your goal. Some people get tired of doing one thing and they have to do the other part. So if this is my formula, so 1 minus probability X equals 7, don't forget the 1. So this is 1 minus, so I put the formula out as 7, choose 7. Probability of death is 70%, so 0.727, also 7. And then that leaves for not death or surviving is 0.3. and there's nothing left for failures. So that's the result, and it simplifies very neatly into this being 1 and this being 1. So all you have to do is take 1 minus 7 to the power 7. 0.7 to the power 7 and get your answer. Now the answers are very close, so you have to be accurate here. The responses, the choices are very similar, so you have to be very accurate. So let's get our calculator. So 1 minus 0.7 to the power 7. Like, you could not do this unless your calculator honors order of operations. So you need to make sure if you're not getting the same answers as me, then let me know if you can't figure out how to set it up for order of operations. And that's it. Okay, the last one is the most challenging. I'm going to do it. If you have to go, like I said, you can go. But we're on a roll here. You're going to be able to understand the next one if you've understood the prior ones. If you've not understood any of these, work this week and let me know if you need to meet to clarify anything. But I'm going to assume by next week that you've covered this and that you understand. All right, so let's do the last one. And there's more problems, but this is a good one. So remembering SARS. There are 4 patients. With SARS in a Toronto hospital who are monitored by 2 staff members. Suppose the probability at any one time of a patient requiring emergency attention by a staff member is 30%. Assuming the patients have independently behave independently, what is the probability at any one time there will not be sufficient staff? So I said, your question surrounds what is in the last sentence, right? Or the last set of statements. So I imagine this is a binomial problem, so I'm going to set it up. X, N, P, K. What is N? Why my font is so big? What is N?
4.
The number of patients, 4, right?
Mhm.
And what is the success?
Not having stuff, no stuff for the person.
Okay, so separating between the repeated experiment, the repeated phenomenon, and the overall. So each time we look at a patient, because that's what we're observing, was there enough staff, right? So success is sufficient staff or enough staff to attend. Now, this is a very practical question, right? Because you have to make sure that you have enough staff on hand, given the probability of an emergency. So this resonates quite well with the last 4 years of or 3 years of pandemic and needing enough resources in hospitals, including human resources. So what's the chance then of a success? So is a success not enough staff or enough staff? Okay, so I think okay, let me do it this way. Is success enough staff or is success emergency? When we look at a patient, what are we looking at? Are we looking to see if there's an emergency? So remember, the trials are the patient. So observing the patient, are we looking for an emergency or enough staff? Which one is the correct? So again, teasing apart each incident versus the overall. I think this will be better to generate the answer. You guys aren't getting it. So what is the P? What are you told about the P? Let's backtrack a little bit. Thank you, Erica. What are you told about the P? What's the P? Aha. So P is the probability of emergency each time we look at an individual. So again, what is a success? How do we define a success? As an emergency? Aha. So this is a success. The other thing is not a success. Enough staff is the overall question, and we're going to define that when we get to K. So far we've got N, we've got P, because we understand success is an emergency each time we look at a patient. So what's the possible amount of emergencies we can have? 0 emergencies, 1 emergency, 2 emergency, 3 emergencies, and it's up to 4, right? So K will capture the, will help us get the answer to the question. The overall question is not enough staff. So which of these would indicate not enough staff? If there's 1 emergency, do we have enough staff with 2 staff members? So the underlying assumption here is that you need at least one staff member to attend. It doesn't say that, but. So back to my question. So if there are 0 emergencies, do we have enough staff? Yes. If there's 1 emergency, do we have enough staff? Yes. If there are 2 emergencies, do we have enough staff? Yes. But if there are 3 or 4, so Marlo, you're close. Marcos is right. Right. So that's how we know. So this is like the most challenging. So if you figured this out or almost figured that out, that's good. So you need 3 and 4. You need to calculate those and add those up. And that will give you your answer. So can I leave you to do that? And we can end at 12? Or do you want to see me calculate that? You're making me think I need to do it. X equals 3 plus X equals 4. So this would be, oh, let me move this away. Okay, I can do it quickly. I'm gonna do it quickly though. Okay, so X equals. So 4 choose 3 and 4 choose 4, and then the probability is 0.7, 0.7. For emergency, right? No. Why? See, I always remember the old numbers. It's 0.3. So funny. This is the Lassa fever one. Why is my thing so big? Okay, so then 0.3 and 0.3, and I'm going to put 3 successes, sadly, and 4 successes there. And then the other one is 0.7 with 1 and 0.7 with 0. And you see how things simplify quite nicely. This becomes 1, and this becomes 4, and this becomes 1. And then let me just get rid of this because it's taking my space. And then I put this into my calculator and I store it. So 4 times 0.3 to the 3 times 0.7 equals 0.0756. Let me make that a little bigger. And store 1. And then the other one is 0.3 to the power 4 times, oh, that's it, 1. And store 2, and then recall 1 plus recall 2 gives me my answer. What was recall 2? So this is 0.0081, and you sum them. Any questions about what I'm doing with those storage keys? So that's my final answer here. And we got the answer. Hope you feel empowered with technology. All right, so continue to study, work ahead through the sampling distribution of a statistic. And if you want, you can also go back and see those videos that I shared with you at the very beginning. They have some review of sampling distribution as well. But watch all my stuff first. If you need more, you can go back to the decisions through data set of videos. Actually, I should put those on your platform. I'm going to put those in the platform so you know which ones to watch. And it's just nice, it's relaxing, and those 15-minute videos are a nice summary, very professionally done. So that's it for everybody. If you have any questions, be in touch if you need to meet with me. Otherwise, you have a assignment due on Wednesday. I will post a new one for next Wednesday. I mean, you know, not the coming week, but the following week. And that will be with this binomial material and the sampling distribution. And I'll start mixing things up after that, so you can keep practicing the old material, okay? So I'll put the decision through data videos throughout the Moodle platform so you can reference and go through and review those two to remind you how to do this stuff. All right, thank you very much. Have a
So you have a few minutes.
yes.
Okay.
So I'm going to stop the video then. And the recording. Where's my